Hi, this is Rajnikant Mishra. This is the second video in Permutation and Combination series. Today we are going to discuss top 10 MCQs on the problems of arrangement of digits. But before that, let's take a quick view of previous lecture. In it, we discussed about the definitions of permutation and combination, the real-life examples of permutation and combination, the difference between them, the counting principle, NCR formulas with proof, and the use of binomial theorem in permutation and combination. If you haven't seen that video, the link is given in the description box and also in the I button. You have to watch that video first, then after you will be able to understand today's lecture. Question number 1. How many 3-digit numbers can be formed with the digits 1, 2, 3, 4 and 5? Here we use counting principle. Case 1. The repetition of digits is allowed. In case of 3 digits, we have 3 positions: unit place, tens place and hundreds place. For the hundreds place, we have 5 choices: 1, 2, 3, 4 and 5. For tens place, again we have 5 choices because repetition is allowed. And for unit place, again we have 5 choices: 1, 2, 3, 4 and 5. Now multiply these numbers. 5 into 5 into 5 is equal to 125. It means total number of arrangements are 125. Now case number 2, the repetition of digits is not allowed. Again we have 3 positions: unit place, tens place and hundreds place. But for first position, we have 5 choices: 1, 2, 3, 4 and 5. For second place, 1 choice is removed, so we have 4 choices. And for third position, 2 choices are removed, so we have only 3 choices. Now multiply these numbers. 5 into 4 into 3 is equal to 60. So the total number of arrangements are 60. Question number 2. How many 3-digit numbers can be formed with the digits 0, 1, 2, 3 and 4? Case 1. The repetition of digits is allowed. For 3 digits, we have 3 positions: unit, tens and hundreds. For first position, we have only 4 choices: 1, 2, 3 and 4. Because if you put 0 at hundreds place, then 0, 1, 2 is not a 3-digit number, it's a 2-digit number. For tens place, we have 5 choices: 0, 1, 2, 3 and 4. And for unit place, again we have 5 choices. Multiply all these numbers. 4 into 5 into 5 is equal to 100. So possible number of arrangements is equal to 100. Case 2. The repetition of digits is not allowed. Again we have 3 positions. For first position, we have only 4 choices. Put 4 here. For tens place, 1 choice out of 5 is removed, so remaining choices are 4. For unit place, 2 choices out of 5 is removed, so the remaining choices is equal to 3. Now multiply all these numbers. 4 into 3 is equal to 48. So the possible number of arrangements is equal to 48. Question number 3. How many 3-digit even numbers can be formed with the digits 0, 1, 2, 3, 4 and 5? Case 1. The repetition of digits is allowed. For 3 digits, we have 3 positions: unit, tens and hundreds. In case of even number, for unit place, we have only 3 choices: 0, 2 and 4. So number of choices is equal to 3. For hundreds place, we cannot put 0 here, so the total number of choices is equal to 5. For tens place, the total number of choices is equal to 6: 0, 1, 2, 3, 4 and 5. Multiply all these numbers, the answer is 90. So the possible number of arrangements is equal to 90. Case 2. The repetition of digits is not allowed. Again we have 3 positions. In case 1, put 0 at units place. So we have only 1 choice. For hundreds place, only 5 choices are remaining, so put 5 here. For tens place, one more choice is removed, So put 4 here. 5 into 4 is equal to 20. Means 20 arrangements when 0 is at unit place. Case 2, when 0 is not at unit place. In this case, we have only two choices, 2 and 4. Put 2 here. Now out of 2 and 4, one option is removed. 0 can't be at hundreds place. So for hundreds place, we have only 1, 2, 3 and 4. 4 choices. Now for tens place, 2 choices out of 6 are removed. So the remaining choices are 4. 4 into 4 into 2 is equal to 32. Now add 20 plus 32 is equal to 52. So the possible number of arrangements is equal to 52. Question number 4. How many numbers between 1800 and 4600 can be formed with the digits 0, 1, 2, 3, 4, 5, 6 and 7 if repetition is not allowed? Here, first we calculate the total numbers from 2000 to 5000, then 1800 to 2000, then 4600 to 5000. Let it be X, it is Y, and it is Z. Then the required answer is X plus Y minus Z. Step number 1, the numbers between 2000 to 5000. All numbers have 4 digits, so we have 4 positions: unit, tens, hundreds and thousands. For first position, we have only 3 choices, 2, 3 and 4. 4999. So put 3 here. Now one choice is removed. So for hundreds place, we have only 7 options remaining. For tens place, 2 choices are removed. So the remaining number of choices is equal to 6. And for unit place, 3 choices are removed. So number of choices remaining are 5. Now multiply all these numbers. 3 into 7 into 6 into 5 is equal to 630. So total numbers between 2000 to 5000 are 630. Now we find the numbers between 1800 to 2000. We have 4 positions. At first place, we can put either 8 or 9, but both the numbers are not available in options. So we can say with given digits, no such number can be formed. Our total numbers is equal to 0. Now we calculate the numbers between 4600 to 5000. We have 4 positions. At first place, we can put only 4. So number of choices is equal to 1. At second position, we can put either 6 or 7. So number of choices is equal to 2. For third place, 2 options out of 8 are removed. So the number of choices remaining are 6. And for unit place, 3 options out of 8 are removed. So the remaining choices is equal to 5. Now multiply all these numbers. The result is 60. Here this is X, this is Y, this is Z. 630 plus 0 minus 60 is equal to 570. So the final result is 570. Question number 5. How many 3-digit numbers can be formed from the digits 0, 1, 2, 3 and 5 which are divisible by 3? Here we use the divisibility rule of 3. If the sum of the digits is divisible by 3, then the number is divisible by 3. By this condition, the required pairs are 0, 1, 2, 0, 1, 5, 1, 2, 3 and 1, 3, 5. Because 0 plus 1 plus 2 is equal to 3, 0 plus 1 plus 5 is equal to 6, 1 plus 2 plus 3 is equal to 6, and 1 plus 3 plus 5 is equal to 9. If we choose the pair 0, 1, 2, here we have 3 positions, unit, tens and hundreds. At first place, we cannot put 0. The number of choices is equal to 2. For second place, 1 choice out of 3 is removed. The remaining choices is equal to 2. And for third place, 2 choice out of 3 is removed. So the remaining choice is equal to 1. 2 into 2 into 1 is equal to 4. If we choose second pair 0, 1 and 5, then similarly the total number of digits is equal to 4. And when we choose the pair of 1, 2, 3, we have 3 positions. For first position, we have 3 choices. Now for second position, 1 out of 3 is removed, so remaining choices is equal to 2. And for third position, we have 1 choice. 3 into 2 into 1 is equal to 6. So the total numbers is equal to 6. Similarly, for fourth pair, total numbers is equal to 6. Now add all these numbers. 4 plus 4 plus 6 plus 6 is equal to 20. The 20 is the final answer. Question number 6. Find the sum of the 4-digit numbers formed from the digits 1, 2, 5 and 7 if repetition of the digits is not allowed. Here, first we find the possible number of arrangements. We have 4 positions. For first position, we have 4 choices. Repetition is not allowed. So for second position, we have only 3 choices remaining. And for third position, we have only 2 choices. And for unit place, we have only 1 choice. 4 into 3 into 2 is equal to 24. It means 24 numbers can be formed. To understand further process, let's take an example of digits 1, 2 and 3. With 1, 2 and 3, we can form 6 numbers. And these numbers are 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, 3, 2, 1. Now see, at unit place, 3, 2 and 1 are repeated equal number of times. Similarly, at tens place, equal number of times, and similarly at hundreds place, equal number of times, which is equal to 2. Or we can say 6 numbers by 3 digits is equal to repetition cycle of 2 at each place. So in this case, the repetition cycle is equal to 24 numbers by 4 digits is equal to 6. So we can say when we write down 24 numbers, then at units place, 1 is repeated 6 times, 2 is repeated 6 times, 5 is repeated 6 times, and 7 is repeated 6 times. So the sum of all unit digits is equal to 6 into 1 plus 6 into 2 plus 6 into 5 plus 6 into 7 is equal to 6 common into 1 plus 2 plus 5 plus 7, which is equal to 6 into 15 is equal to 90. Now sum of the numbers at unit places is equal to 90, sum of the numbers at tens place is equal to 90, sum of the numbers at hundreds place is equal to 90, and sum of the numbers at thousand place is equal to 90. This is unit place, tens place, hundreds place, and thousands place. The total sum is equal to 99,990. Or you can do this. Put 0 here. Add this 9 into 90. 90 plus 9 is equal to 99. Put 9 here. Again, forward this 9. 90 plus 9 is equal to 99. 9. Again, forward this 9. 90 plus 9 is equal to 99. 99,990. This is our right answer. Question number 7. Find the sum of the 4-digit numbers formed from the digits 0, 1, 2, 3 and 4 if the repetition of the digits is not allowed. Here we first find the possible number of arrangements. We have 4 positions. We cannot put 0 here. So for first position, we have only 4 choices, 1, 2, 3 and 4. For the second position, 1 choice out of 5 is removed. So we have only 4 choices. For third position, 2 choices out of 5 are removed. So the number of choices remaining is equal to 3. And for fourth position, 3 choices out of 5 are removed. So the remaining number of choices is equal to 2. 4 into 4 into 3 into 2 is equal to 96. So the possible number of arrangements is equal to 96. Here all numbers are of 4 digits. At first position, 0 is not present. and we have only 1, 2, 3 and 4, means only 4 digits, and total number of arrangements is equal to 96. The repetition cycle is equal to 96 numbers by 4 digits is equal to 24. Means 1 repeated 24 times, 2 24 times, 3 24 times, and 4 24 times. So sum of all numbers at thousandth place is equal to 24 common 1 plus 2 plus 3 plus 4 is equal to 24 into 10 is equal to 240. Now we have to find the sum of all numbers at unit place. At unit place 0, 1, 2, 3 and 4 all are repeated. We have 4 positions. First put 0 at unit place. We have only one choice. For first position, one choice is removed, so remaining choices are 4. For second position, 2 choices are removed, so remaining is 3. And for third place, 3 choices are removed, so remaining is 2. Means 4 into 3 into 2 is equal to 24. Means there are 24 conditions when 0 is at unit place. And in 96 minus 24 is equal to 72 cases, 0 is not present at unit place, or in this case 1, 2, 3 and 4 are present. Repetition cycle is equal to 72 numbers by 4 digits 1, 2, 3 and 4, which is equal to 18. Means 1, 2, 3 and 4 all are repeated 18 times each. Now the sum of all numbers at unit place is equal to 24 zeros and 18 ones, twos, threes and fours is equal to 180. Similarly, sum of all numbers at tens place is equal to 180, and sum of all numbers at hundreds place is equal to 180. This is our unit place, this is tens place, this is our hundreds place, and this is our thousands place. So the sum of all 96 numbers is equal to 2,59,980. This is our final answer. Question number 8. How many 5-digit numbers can be formed from the digits 1, 2, 3, 4 and 5 such that the odd numbers do not occupy the odd places? Here all numbers are of 5 digits. First, second, third, fourth and fifth. Here we have 3 odd positions. Now according to question, we cannot put odd numbers at odd positions, or we can put only even numbers at odd positions. Here there are only 2 even numbers, 2 and 4, means for first position we have only 2 choices. For third position we have only 2 choices, and for first position we have only 2 choices. And at even positions we can put any of these 5 numbers. So number of choices is equal to 5 and 5. Now multiply all these numbers. The final answer is 200. Question number 9. How many 4-digit numbers can be formed from the digits 0, 1, 3, 5 and 8 such that all numbers are divisible by 5? Case 1. Repetition is allowed. Here we have 4 positions. Because all the numbers are divisible by 5, so we can put either 0 or 5 at unit place. It means for unit place we have only 2 choices, 0 and 5. At first place we cannot put 0, so the number of choices are 4, 1, 3, 5 and 8. At second position we can put any of these numbers, so number of choices is equal to 5, and at third position number of choices is equal to 5. 4 into 5 into 5 into 2 equal to 200. It means in case repetition is allowed, there are 200 numbers can be formed, 100 with 5 at unit place and 100 at 0 at unit place. Case 2, repetition is not allowed. If you put 0 at unit place, means only one choice. Then for first position, only 4 choices are remaining, 1, 3, 5 and 8. For second position, 2 options are removed, so remaining number of choices is equal to 3. And for third position, 3 options are removed, so the remaining number of choices is equal to 2. 4 into 3 into 2 is equal to 24. If you put 5 at unit place, means number of choices is equal to 1. You cannot put 0 here, so the remaining choices are 1, 3 and 8, which is equal to 3. For second position, 2 choices out of 5 are removed, the remaining choices is equal to 3. For third place, 3 choices out of 5 are removed, so the remaining choices is equal to 2. 3 into 3 into 2 is equal to 18. Now add 24 and 18, the final answer is 42. Question number 10. How many 5-digit numbers contain exactly 2 4s in them? Here all are 5-digit numbers. In decimal number system, we have 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Case 1. When the 10,000 digit is 4, means 1 4 is fixed at first position. Now you can put second 4 at any of these 4 positions. This can be done by 4 even ways, means 4 factorial by 1 factorial into 4 minus 1 factorial, which is equal to 4 factorial by 3 factorial is equal to 4. Suppose you put second 4 here. For this position we have 9 choices because we cannot use 4 again. For this position again we have 9 choices, and for this position again we have 9 choices. So possible number of arrangements is equal to 4C1 into 9 into 9 into 9. In case 2, when 4 is in place other than the 10,000 place, it means you cannot put 4 or 0 here, means for first position we have only 8 choices. And out of these 4 places, 2 places are reserved for 2 4s. Suppose you put 2 4s here and here, then there are 2 positions are vacant, and at this position we cannot put 4, so the number of choices is equal to 9, and for this position the number of choices is equal to 9. Now the possible number of arrangements is equal to 8 into 4C2 into 9 into 9. Here 4C1 is equal to 4, and this is 9 cube. Here 8 into 4C2, 4C2 means 4 factorial by 2 factorial and 2 factorial, which is equal to 4 into 3 by 2 is equal to 6, means 8 into 6 into 9 square. Now add both of them, 4 into 9 cube plus 8 into 6 into 9 square, 9 square common, 9 into 4, 36, and 8 into 6, 48. 36 plus 48 is equal to 84. 9 square is equal to 81. 81 into 84 is equal to 6804. So the final answer is 6804. Now NCR formula. In the previous video, we discussed 6 important NCR formulas. The link of that video is given in the description box. Now here we are going to prove this formula. Here the left hand side can be written as sigma r is equal to 0 to n NCR by r plus 1. If you put r is equal to 0, it becomes NC0. If you put r is equal to 1, it becomes NC1 by 2. If you put r is equal to 2, it becomes NC2 by 3. And similarly, if you put r is equal to n, then it becomes NCn by n plus 1. Now multiply n plus 1 in numerator and denominator. Now take 1 by n plus 1 common, n plus 1 by r plus 1 into NCR. In the last video, we have proved this formula n plus 1 by r plus 1 into NCR is equal to n plus 1 CR plus 1. So replace it with n plus 1 CR plus 1. We can write it as sigma r is equal to 0 to n plus 1 CR plus 1. Now expand this expression 1 by n plus 1 into, put r is equal to 0, n plus 1 C1, r is equal to 2, n plus 1 C2, dash dash dash, put r is equal to n plus 1 C n plus 1. Now add n plus 1 C0 and subtract n plus 1 C0. This n plus 1 C0, n plus 1 C1, n plus 1 C2, dash dash dash, n plus 1 C n plus 1 can be written as 2 to power n plus 1 minus n plus 1 C0. You can check this formula in the last video. Now 1 upon n plus 1 into 2 to power n plus 1 minus n plus 1 C0. Now n plus 1 C0 is equal to 1. Now this is your right hand side, 2 to power n plus 1 minus 1 by n plus 1. Hence proved. Here is your homework. Question number 1. How many such words can be formed from the letters of the word practical which start with a vowel and end with a consonant. Question number 2. How many ways do the letters of the word practical be arranged so that all vowels come at odd places only? In the next lecture, we will discuss top 10 word formation problems. If you like this video, hit the like button, share it with your friends, and never forget to subscribe and hit the bell icon so that you will never miss any important update. Thank you.